Assalamu alaikum everyone. Today in this video we will talk about the improvements of the gas power plant system. So the first improvement which we will be discussing is the reheater, as it was also in the steam power plant system. So the mechanism of this reheater is same as it was in the previously steam power plant system. So what happens that as the steam goes from the compressor to the combustor, and from there it goes to the turbine stage 1. Then again, from its outlet, that air is again enters in the combustor, as it is shown the reheater combustor. Then it goes into the second turbine stage. Now through this way it becomes more efficient, as the same air is used again for the second stage of the turbine. Now this is the TS diagram of the reheater. As you can see, from 1 to 2 it is the compressor, then from 2 to 3 is the combustion, and from 3 to A it is the first stage of the turbine. From A to B it is the reheater stage, and from B to 4 it is the second turbine stage. This cycle can continue if we use the same air as as it goes from 4 to 1. Now in the reheater, the enthalpy of points A and B will be calculated same as the enthalpy of point 2 and 3 is calculated. Now the second improvement is of intercooler. Now in this system, as the air comes into the compressor, then from compressor it is cooled into the intercooler, and the heat is removed, as you can see, Q dot out, and then again that cooled and compressed air is go into the second stage of the compressor, where it is more compressed and its pressure is increased more. So this is the TS diagram of the intercooler. As you can see, there are three pressure lines, as from 2 to D is the first compressor stage, then from D to C is the intercooler, and from C to 1 it is the again compressor stage. Now the enthalpies of the 2 points in the intercooler, which are C and D. The D point enthalpy will be calculated at a temperature which will be given from the question, it will be mentioned that at which point it is cooled, and the enthalpy of stage C will be calculated as we use this formula. The PRC divided by PR1 is equals to PC by P1. In this, the PRC value will be founded, and we can see the enthalpy at this point from the table A22. Now the third improvement which we will discuss is of a regenerator, or you can also say as the heat exchanger. As the air is compressed into the compressor, it goes into the regenerator, where its temperature will be exchanged with exhaust gases which are coming out of the turbine. As you can see, as the whole cycle proceeds from combustor to turbine, the exhaust gases will be generated at the end of the turbine. Its heat is exchanged with the compressor. The compressed air which is coming out of the compressor, what happens that this increases the temperature of the exhaust of the compressed air which goes into the combustor, and over combustion, the less Q in is provided, as the air is previously heated enough, so this increases the efficiency of the whole power plant. Now, this is the TS diagram of the heat exchanger, as the air is compressed from stage 1 to stage 2. Then from, as you can see, there is point X between 2 and 3. It is of the heat exchanger, as from 2 to X it goes into the heat exchanger, and from X to 3 it goes into the combustion. Then from 3 to 4 the turbine stage, and from 4 to X, as you can see, there is also a dotted line which shows that heat is exchanged with the compressed air which is coming out of the second point, as you can see. Now the enthalpy of the stage X will be calculated in such a way, as you can see. The efficiency of the reheater is equals to the enthalpy, which will be find it at point X, minus enthalpy of stage 2 divided by the enthalpy of stage 4 minus enthalpy of stage 2, and we will rearrange it and find the enthalpy of the stage X. The point Y, as you can see in the TS diagram, is the output of the exhaust gases, which will be from the regenerator, and it can also go into the compressor, as that air is again reused, as you can also see in this layout. Finally, we will combine the all three improvements into the single power plant. As you can see in this layout, there is intercooler between two compressors, 1 and 2, and there's also two combustors, as you can see, between two turbines, 1 and 2. So as the air enter into the compressor as stage 1, it goes into the intercooler, compressed uh, uh, from stage 2 to stage 3 is the intercooler stage, and that intercooled and compressed uh, air goes into the compressor, where it is again compressed and passes through the regenerator, where heat it will be air exchanged with the exhaust gases, which will be coming out of the second stage of the turbine. Now at from point 5 to point 6 is the first combustion stage. Then it goes into the turbine 1, and then from the turbine outlet it goes into the second combustion state, and then again it goes into the turbine 2, and from that stage it goes into the regenerator, where heat will be exchanged with the compressed air, which will be coming from the fourth point. This is the TS diagram of all the improvements in this system. The S points, which are 4S, 2S, 7S, and 9S, are shown as it is totally isentropic, that their entropy is same from 3 to 4s, 1 to 2s, 6 to 7s, and 8 to 9s. If it isn't asentropic, its point are shown as 2, 4, 7, and 9. So that's it for the gas power plant system. Now, in the next videos, I will discuss some other thermodynamics topic. So, for till then, that's it for today. So, like and comment in this video and subscribe my channel and share it with others. So, thank you so much. Till then, Khudafiz.